Hello, everyone. Thank you for sticking with me until 5:30 p.m. on a Saturday. Today, I'm going to be talking about the open source repository browser that I've been working on for the University of California system. This has been mentioned in some other talks, so hopefully, there's some context around it. So first, a little bit about me. My name is Juanita. I am Colombian. I'm originally a mathematician, but I turned into a software developer a couple of years ago. I was a developer for Spider, which is an IDE for Python. So I maintained Spider for some time before joining my PhD. Now I'm a PhD candidate at UCSC, and I work very closely with the Open Source Program Office at UCSC. I think all of you were at Virginia's talk, so I don't have to explain what an Open Source Program Office is. Yay. And I'm also a community lead for the Scientific Python project, which is kind of like a group of people who are trying to coordinate the Scientific Python ecosystem. So I work very closely with a lot of the developers from Python libraries. And I'm also one of the communications chairs for the SciPy conference, again, bringing people from Scientific Python community together. But today I'm not going to talk about any of that. I'm going to talk about the work that I do as a PhD student. So a little bit of background. This work, as Virginia also mentioned, is funded by a Sloan grant that we got for multiple universities of California. And I'm going to be talking specifically about the discovery approach. So the work that I'm going to be talking about today, the goal is to kind of find all the open source work that it's been done within the University of California system. I think mainly because the OSPOs want to understand who's out there doing software and how they can serve them. So that's kind of like the main purpose of this project. So why an open source repository browser? We want this to be a tool for mapping and classifying projects from the UC system. We want to help researchers and students on like institutions to like discover and connect projects. For example, like connect them with funders or connect them between each other so that they can collaborate. And we also hope that this can have like impact beyond UC. I mean, we're going to be talking specifically about UC data and the UC system, but hopefully this can be a model for other universities to improve the open source project discovery. So what's on the menu? This is a recipe. So the main dish for today, it's going to be mainly about how I collected the database for the open source repository browser. Huge disclaimer, this is a work in progress. So there's still a lot of things that are happening. The first part is gonna include like the data collection, mainly using GitHub data classification. So I'm gonna talk about like how I determine the affiliation with the university, and then also what are the project types that people are like using in GitHub, and then some insights from the data that I collected from the open source work being done at UC. And then the last and much smaller part of the talk, I'm going to talk about the showcase, which is actually like a software catalog that we are hoping to build for some specific projects to literally just showcase their work and help them also like connect with other people within the ecosystem. So for the data collection, I used some like campus keywords. So the name, the acronym, the domain, and some alternative names. So for example, for the University of California, Santa Cruz, we call it also UC Santa Cruz. This kind of works the same with all of the UC campuses. And then I used some of the repository attributes to find these keywords at. And the main way that I used, like collected the data, was using the GitHub REST API. So the first thing that I did was just building search queries. I use each of the keywords in each of the attributes, except for like the email, which I specifically used it in the like email attribute of the repository. And then using the GitHub search API, this just gives me like a JSON with a bunch of information of all the repositories that have any of the keyword matchings, like from the queries. And then the next step that was kind of key was to build a database, right? Because we can collect all this data, but one of the main issues is we want to be able to interact with the data, grow it as much as we can. So this kind of like the first thing that I did was starting building a database with a bunch of repositories. I also added extra information that does not come like by default with like the search query from GitHub. So extra metadata like the README, the code of conduct, contributing files, security policies, issue, and PR templates. Mostly because I wanted to get some idea on like the open source practices from these projects. And these other two things are information from the contributors and the organizations of the projects, because this is how I eventually identify the affiliation. So, for example, the most kind of clear indicator of a project being affiliated with a university is when the like owner is actually an organization in GitHub that has either the URL or the email like that includes the domain of the university. So a lot of research groups at universities have they create GitHub organizations and they include their websites or their emails or things like that. And when that includes the domain, it's kind of clear that they are part of the university. So, I mean, what I'm trying to find here is the work that it's been done at the institution. And of course, you can imagine that there's a lot of repositories out there that have a lot of keyword matches from the University of California system that are not necessarily related to the people at the university. So doing this, I was able to collect around 52,000 repositories from the 10 universities of California. So huge disclaimer, GitHub's API has a lot of limitations. There's limitations per hour, there's limitations per query. This data is not exhaustive. There is for sure way more data out there, but this is kind of like an initial data set that we're using to like getting some conclusions. Something interesting is that I only found from like this 52,000 repositories around 4,800 organizations, which means one of two things. The first one is a lot of concentration, like a lot of projects are developed by the same organization, or that a lot of projects are actually mainly developed by users in GitHub and they don't use the organization like in GitHub. So now I'm gonna convince you why I need to actually filter this data and why I can't say that those 52,000 repositories are actually affiliated with the University of California system. For example, there is a bunch of collections of things in GitHub, like collection of interesting computer science resources. This has 257 results, and I bet you that at least maybe 80% of them have keyword matchings from the University of California system. And these are just resources that students put up there. They're like, oh, these are the 100 universities that you can do computer science majors on. And they have keyword matchings, but these are not work that it's been developed at the university. The other very interesting case is, like, did you know that there's 2 universities out in the world that have this exact same acronym as the University of California, Santa Cruz? So yeah, I actually run into some of these situations where I was like, oh yeah, this is interesting. This is not Santa Cruz, but they have exactly the same acronym. So we need to do some filtering of the data. So the first thing that I did was to come up with what exactly means to be affiliated with a university. And then, I mean, I'm not gonna read the definition, but basically I divided into like 5 key things. The first one is research group affiliation. So things that are developed by research groups at the university. That one is sort of easy in most of the cases because they have organizations that have either the URL or the domain, like the email that contains the domain of the university. Contributor affiliation. So someone in the contributors of the repository is affiliated with the University of California. It could be that it says it in the profile or they have the email from the university. Institutional development. So projects that are being developed by departments like IT or the OSPO or libraries at the university. Official sponsorship or of ownership. This is a little bit less clear, but pretty much it says in the README that it's being developed by or at the university. And then the last one was a little bit tricky because a lot of the University of California's have like educational materials in either Coursera or edX or some of these platforms. So it's tricky for me to decide whether I want to include this. I did because it was actually harder to filter it out. So things like online resources, either from like the teaching side or the learning side, like students who are developing materials to solve these courses. So I'm going to go very fast through like how I did this because I think it's more interesting to show you what I found. But pretty much this is kind of like the baseline was what I used to test my actual methods. This is not what I did. This is the baseline that I used to test. And this is what it does is pretty much just finding keyword matches in metadata fields of the repository. So I have, for example, a bunch of the information that I collected from the repositories. So the full name, the homepage, the README, description, owner, other details about the organization. And I also use some details from the top contributors. So for example, the login, the bio, the company that it's like publicly in GitHub, and the email. And then I computed a score that was based on how many keyword matches they had in each of these fields. And I gave more importance to those fields that are clearly more indicative of the affiliation. Like if a contributor has an email of the university, that is more important than if just shows up in the README. That wasn't enough. I'm going to show you later that does not work. And the reason it doesn't work is because context matters. Even if you compute the number of like keyword matches in, for example, a README file, that doesn't really tell you what the relationship is with the university. So in conclusion, context matters. And the reason I decided to then try like text embeddings and large language models is because those two methods help with correlating the context with the keyword matches. So in these two methods, I pretty much use exactly the same metadata. So repository information, organization details, and the contributors, the top two contributors. For the text embeddings method, I pretty much concatenated all of the metadata into a single text. I had to manually label a bunch of repositories because I was using supervised learning. So that includes, I need to manually label repositories. So I did only this for 3 universities just because it's a lot. So I took 200 repositories from 3 different universities. I'll show you later which ones. And then I use these embeddings models. If you're not familiar with that, what they do is they turn a bunch of text into numbers that mean something. They tell you information about that text. And then with that set of numbers that ends up being like a gigantic metrics, you can implement machine learning models in order to compute predictions. I tried multiple machine learning models. The best one was support vector machines, but it doesn't really change that much when you try different models. I think what is relevant is actually the data that you're using. So that was method number 1. Method number 2 was just using large language models. So using, I used specifically the models like 4.0 and 3.5 from GPT, from OpenAI. And in the prompt, I asked the model to compute the likelihood that a repository belongs or not to a university. For these, I gave the definition that I created of what it means to belong to a university, plus all the information metadata that I just showed you, the list of 15 attributes. And additionally, the information of the university. So the name, the acronym, the alternative queries, and the domain. And then the task was to compute a probability and give an explanation on why that probability. So I'm not going to go too deep into this, but this is just to show you that I tested my models and that I did pay attention to the performance of them. These are the results for 3 universities. So I actually had to compute other manual labels to have a test set in order to compute these results. And then if you're familiar with RSE curves, they say kind of how able is your model to distinguish, in this case, the positive class versus the negative class. So 0 meaning my project is not affiliated with the University of California, 1 meaning it is affiliated. In this graph, the curve that is very, very close to the diagonal is the baseline that I showed you for the score-based classifier. It clearly doesn't work. It is very close to just randomly guessing. But the other models have a much better performance. One of the things that I found very interesting is that LLMs are not necessarily better in 100% of the cases, which was very surprising to me because nowadays LLMs are the answer for everything. But this proves that sometimes that's not the case. the data set impacts the results. So if you see the University of California, San Diego, the results were not as good for all of the methods that I used. San Diego is a much larger university than Santa Barbara and Santa Cruz. I also found that a lot of the projects in San Diego do not have a README, which is very interesting. So yeah, it was just kind of like the data impacted the results in this particular case. And yeah, the last thing is, this is a hard problem. I no way I'm achieving like 100% accuracy. These are just kind of like me trying to get as close as possible to determine which of these 50,000 repositories belong to the University of California system. And this is what I found. Again, not 100% accurate. From all the 52,000 repositories, only 48% are actually predicted to be affiliated. That's less than half, which means there's a lot of noise out there. It's really hard to find repositories that are being developed by the University of California system. There is some interesting insights here. For example, UC Irvine and UC Merced are two universities where the percentage of affiliated was very, very low. My guess it's because the acronyms are probably used for another million things. So in those cases, the percentage of affiliation is much less. But for the other, it kind of goes between 45 and 60%, like mostly consistently. The second thing that I did regarding the data classification was trying to determine project types. So one of the things that the OSPO was actually very interested in doing is like knowing which of these projects are actually tools that people are developing, which of them are educational materials, or like other types of things that people are doing. So using some other previous resources and taxonomies that have been published before, I decided on these 6 categories to determine the project type of the repositories. The first one is dev, which is like tools or apps or components or APIs or anything that it's like kind of either development or also sort of research. Edu for like educational purposes, including like materials for instruction, but also like projects and assignments from students. Docs, anything related to like non-educational documents. Web for hosting like websites. Data for storing data sets, and then other, which is the it doesn't fit any of the other categories. And then for these, I actually used way less repository information because I thought, I guess, from the full name, the README, the description, it should be kind of enough context to determine which of these project types a repository fits in. I added also some of the popularity indicators like stars, forks, and a number of contributors, because I thought that would give like extra context on which of these types will the project be. And then, yeah, again, same way, I used one of the like the LLMs. I think in this case, I only used the best one that performed for the previous method. I only used the best one in this one. And I just asked the LLM to report which of these 6 types would the repository fit into. And I gave the repository information and this definition. These are the results. So what I found, the results of the performance of my method. So again, I had to label manually a bunch of data. So in this case, I labeled 100 points in order to test each of the universities. And then, so we can see that it's pretty accurate. Like in all of the universities, I got more than 90% accuracy, which is fairly good. I'm reporting the accuracy by project type because it actually varies. So for example, the education category, it's fairly easy to identify. So all of the universities have accuracy of like 96%, which is pretty good. Other things like docs are harder. So there was actually not a lot of them. There were only 4 out of the like 300 points. And those ones are very hard to identify. So yeah, that one is kind of like 0 accuracy. And then other things like the dev are sort of easy, but for San Diego particularly, it's harder. So something's going on with San Diego there. These are the predictions on the project type distribution. So I only computed this for the 25,000 repositories that had already been predicted as affiliated. So not that's 52K like originally, but the 50% of those who had already been predicted as affiliated with the university. And then, as you can see in like the little pie, the more than 50% of the projects are actually like educational resources. So either teaching content or like students doing homework or assignments in GitHub. I don't think this is surprising. A lot of professors use GitHub for teaching, and a lot of students use also GitHub for doing their assignments. 30% of them are dev, so tools or some other like research component. And then for data and web have way lower percentages. In like if you look at the table, I know there's like a lot of information, but most of the percentages are very consistent across the 10 campuses. The only kind of outlier is UCSF, where the percentage is kind of inverted. So 50% of the repositories are actually dev, and then around 23% are educational. My guess it's because UCSF, I think it's the only one from the 10 campuses that does not have undergraduates. They only have a graduate program. So it's very likely that most of the work that happens in GitHub is actually research related and not necessarily instructional. So this is some of the insights from the data that I collected. So on the left side, I did a plot on like the language distribution, and this is plotted by project type. So the bar on the left is actually just for reference, so that you know kind of like how many the percentage of like each of the different project types. Some interesting insights from these: 17% of the projects use Python. This is actually the most popular language. This is actually consistent with the latest like GitHub open source report from like 2024, where Python was actually the most popular language also. And if you see, I mean, most of the projects that use Python are actually development projects. But if we look at the educational ones, that are the ones that are like lighter orange, Jupyter Notebooks is actually the most common language for those particular education-related projects. Other languages that show up to be popular: HTML, C++, JavaScript, all the way to C and R. On the license distribution, I think this is one of the most interesting insights, is that 70% of the projects collected do not have a license. I don't think it's that surprising. A lot of the projects are not meant to be open source. A lot of the things that are in GitHub that have been collected with this are probably just things that people put out there because they're using GitHub as a Google Drive, sort of. So it's not necessarily that people are not using licenses. It's that there's a lot of projects there. There's a lot of projects there that are not meant to have a license. However, I did look into the kind of dev part of the projects that were in the non-license, and it's actually 51%. So half of the projects that were identified as dev do not have a license. No comments on that. The most popular license is MIT. However, so the bar that says other actually has kind of like a compilation of all the licenses that were below 1%. So that kind of says that there's a lot of diversity out there. I mean, 12% for being the top license, it's still a lot if you take into account that only 30% have a license, and 12% is like more than the third part of them have MIT. So it's still, I would say MIT very popular by far, but there's a lot of diversity on license usage as well. And the other interesting insight that I wanted to get was on community practices. So the things in the bottom on the left plot are what GitHub calls community standards. So these are indicators of some of the things that projects should do for keeping like a friendly community. So yeah, from like README, description, license, contributing guide, issue templates, code of conduct, PR templates, and security policy. We can see that almost all the projects have a README, so 91% of them have a README. If we go look at the description, it's actually around 70%, so way less. The license, we already mentioned that only 30% of the projects have a license. And then if we look at the other practices, it's kind of sad because there's only like less than 2% of the 25,000 projects have a contributing guide or an issue template or a code of conduct or a PR template. And not even talking like the security policy is the saddest thing. It's 0.1%. So, I mean, there's clearly a gap there. I think that this informs some of the things that like we can see that academic open source is lacking in terms of security, in terms of community practices. In the plot of the right, I did an analysis of only the repositories that were dev on the dev category, so like the tools, applications, like more kind of research focused. And I wanted to see how the popularity of these projects impacts the community practices. I know that stars is not the like ultimate identifier of popularity. I know there's a lot of ways to measure popularity. I picked stars just because it was kind of like the direct one that I could use from the data that I collected. But this is in like no way the truth of popularity. So what I did was I split the projects into buckets depending on the number of stars. So from 0 to 10, from 10 to 50, 50 to 100, 100 to 200, and then more than 200 stars. And then I computed the percentage of the projects within each bucket that have any of these community files. So for example, in the top row, you can see that 73% of the projects from 0 to 10 stars have a description. But then if you go all the way to the ones that have more than 200 stars, 96% of them actually have a description. I mean, so in the first three rows, we see very clear that, I mean, most of the projects do have these, except for the license. But I think it's not surprising that the higher the popularity, the higher the probability that the project has a license. So in the first bucket, it's actually 42% of the projects that do not have a license. But if you go to the more than 200, almost 90% do have a license. So I guess that's good because it means that when people are getting more popular in the repositories, then they care more about these practices. And then if we go to, for example, the contributing guide and the issue templates, there is also kind of like a clear increment of how the percentage increases. It's kind of sad that it only increases up until like 15%. But yeah, I mean, what this means is that from the projects that have more than 200 stars, only 15% of them have a contributing guide and 14% have like issue templates. So again, maybe something to be concerned about. So if you want to read a little bit more about this, I have a preprint. This is the QR code for it. This is the title. Hopefully it's easier to find. It's called Recipe for Discovery. It doesn't have the project type analysis because that was something that I did recently. But from the rest, it has kind of like most of the, the work and more in-depth analysis of like the findings and the methods that I used. I'm gonna let you finish scanning. And then, so now I'm gonna switch and I'm gonna talk about the catalog. So as part of the like repository browser, one of the things that we want to do is build a catalog that will showcase some of the projects that are being developed at the university. These are being collected like sort of manually. So I've been using this initial data set to get these projects. But what I mean by manually is that I have personally looked into each of these repositories and made sure that they are actively maintained and that they are developed at the university and very important that they do have a license. So this repository browser is, we're hoping, a tool that will allow for searching and filtering of these projects. And it will hopefully allow researchers to kind of showcase their work in order to get more funding or connect with more contributors, or build a community around the work that is happening within the UC system. This project is part of Google Summer of Code, so I'm actually mentoring a student who is doing most of the work for the showcase. His name is Param, if you want to go stalk him. He's very good. And I'm gonna tell you first kind of how we've been doing this, but then I'm gonna show you like a spoiler of how it's going. So for this particular part of the project, we're using some information from the repositories. Things that we care about a lot are like engagement indicators, because I think those like show some like what interactions these projects are having with the community already, and we want to help them increase that. And also the organization information. So for this initial stage, I'm only working with projects that are owned by an organization at GitHub that is affiliated with one of the universities. So this means that they have the organization email or URL containing the domain of the university. The second thing that I did was filtering them by the pushed date. So GitHub allows you to collect data on when was the last commit or the last PR merged, like all of these things. And this was mainly to get only active projects, because we want to make sure that they're actively maintained and that people can actually engage with them. We did reach out to projects to get their approval to put them in the showcase, because this is going to be like a public website that we're going to host. And we want to make sure that they're okay with their projects being showcased there. So I've been doing a lot of email sending to get the approvals, and also to collect extra information, because I thought, we thought that it was interesting to have extra information like the funders, which is not as easy to find in the GitHub repository, or the contact information in case they want to be reached out with questions, or maybe like people that are interested in joining their communities. And the topic area, which is something that we want to provide for the browser in order to filter these projects by areas. Spoiler, we're probably going to do this with LLMs as well. Classifying the topic areas with large language models is probably something that will reduce the amount of manual work that we'll have to do. So I'm going to show you how it's going. This is the browser. I'm not going to show you the homepage because it's not ready, but if you go to like the actual browser, this is what shows. And what we have are like the small boxes of each of the projects that we have collected. They show things like the amount of stars, the language, the license. Some of these have like other because we haven't kind of matched some of the license that are maybe misspelled or things like that with the actual name of the license. But ideally, all of the projects should have like a reasonably identifiable license. The university and the number of forks. So we have a search here in order to search by keywords or like anything like that you want to find. And then we also have these other filters. So for example, in this case, we only have projects from 4 universities, but we will have projects from the 10 university in here. So for example, I filter by Santa Cruz, and this gives me like all the projects from the University of California, Santa Cruz. I picked this one because this one is the one that has the most projects. Not because they have more projects, but because this one was the first one that I started reaching out, just because I'm there, so a lot of people already kind of know me. And then you can also filter by languages. It has also multi-filters, so you can like put as many languages as you want, and it will show you like everything that matches any of the languages. And then we also have like filters by license, development team. So this kind of the idea is for us to also show who's doing this work. So if you want to see all the work that has been done by the group VLLA at UCSC, then you can just kind of filter by that. And the last are the topic areas, which I told you that right now we're doing kind of like just manual asking questions to the people about their areas, but hopefully we'll have some automated way to classify them by areas. So if you go to one of these project pages, you'll have here like a one-liner description, which right now it's actually being generated by AI, just because some of the descriptions of the projects that we found are either too long or not like specific enough. So with the context of the description and the README, we've asked one of the models to create like a sort of short description. We also want them to have around the same amount of characters, so it's sort of consistent. And then we have here other indicators, the stars, again, the forks, the views. And then we're able to render the README from like, this is the README from GitHub. And then the license also, so that people can take a deep look at the license if they want to. And then on this side, we also have extra information, again, like the license, the university, the language, and the link to the GitHub repository in case people are interested in contributing or kind of finding more information. Okay, back to the slides. Oh, that was a screenshot in case the link didn't work. So what's next? So the code for finding repositories and classifying them, the affiliation, the project type, all of this is already in GitHub. I will share the link in a bit. But my goal is to make it a tool. I want this to be something that anyone in any institution can use to find the open source that has been done at their own institution. So I'm really going to package it and hopefully get a lot of feedback from the community on how to make it better. There's a lot of limitations. It takes forever to scrape a lot of the data because of the GitHub's like limits. So yeah, just kind of like improve it, make it a tool. Enhancing the data collection. Right now, we're only focusing on GitHub, but there is a plan to increasing that to either GitLab or Hugging Face or other places where people store their open source repositories. We're gonna have to deal with like new APIs, or if they don't have APIs, figure out how to like collect the data in a automated way. And also refining the data classification. As I showed you, the results are not perfect. Some of the campuses have very high accuracy, but some others might not. So improving, like trying other more advanced techniques for data classification is something that it's within the plan. And then this is my favorite, which is supporting projects and improving the metrics. I personally think that this data is very informative of things that we can do to help projects to strengthen their communities. I think the fact that a lot of projects already have more than 200 stars says a lot. They already have a community. They already probably have a lot of contributors out there. And if they don't have a contributing guide, then that's kind of concerning. And that is something that the UC OSPO Network can help a lot with, if it's either with education or templates, or just kind of reaching out to them and being like, oh, maybe you want to think about this. So this is one of my, I think, favorite next steps. And it's figuring out how do we help improve the numbers. Okay, this is my last slide. So if by any chance you are at one of the UC campuses, you can submit, fill this form to appear in our showcase. This is also the QR code to the archive paper, same QR code that before, if you're interested. I have like a newer version of this paper under submission, so hopefully you'll get published, and I will share it, in the networks. And then if you want to reach out, this is my email. This is also the link to the UC OSPO network. There's a lot of events that we publish there, and like extra information on some of the other things that we're doing. And then these are the bottom right are the two links to the repositories that I was talking about. So the first one, Repo Finder, is the one that has all the data collection and classification. And the second one is the one that has the kind of Google Summer of Code related work, which is the actual catalog website. And that's it. Thank you. I think I have like 3 minutes for questions. That was a lot. Yes.
Not a question, but just a comment. Like, as someone who, I'm coming from the Bloomberg OSPO, and sometimes you want to like actually provide funding for open source projects. It's really hard sometimes figure out how to give money to certain projects. And I noticed on your showcase that you don't have any like way to connect with the project directly, or to whether it's like get a sponsor, the open source collective, or an email address. Like having that be more visible and accessible, I think would help potential financial support of the project as well.
Yes. So no, but we did think about that, and actually that was something that I think Virginia suggested, and was to actually putting the contact information of the people that like are developing the project, which is one of the things that we're collecting, but we want to make sure that they're okay with us putting that contact information. Yeah. So that most of the projects have not actually responded to that, so that's why none of them actually have the contact information yet. But that is kind of like our plan, is to have the contact information. We do have the link to their GitHub repository, which yeah, exactly. But ideally we will convince them to give us their contact information in the interest of finding them money.
Maybe a general, I hadn't thought about this, is thank you for bringing that up. Maybe a general link somewhere on the homepage of the showcase to link back to one of us.
Yeah.
Because honestly, the funding would likely go through the OSPO would be the one that would help identify how to do that, because it's not like you can go through the GitHub sponsors or something.
Yeah.
Most of them. So it's actually easier to go through the OSPO. So that's actually a thing I didn't think about. So we can look at it. But yeah.
Yeah, I think ideally it would, the network, I mean the OSPO at each campus could serve as some sort of like bridge between whoever is interested in helping the projects and and the projects themselves. Because if for example we put like a student email and then they receive an email from a company like, oh, we want to give you money, the student probably doesn't know what to do with that. So maybe having like a formal way of connecting with the actual network would be a better idea. Yes.
So is the goal here to identify affiliated repositories or open source repositories?
Both. So I divided actually the talk into two different things, because we are thinking about two different products. So the first product, which is kind of like the database, we're hoping to have some way to explore this data, that it's kind of like a big comprehensive data of everything that is out in GitHub, whether it's open source or not. And the second part of it is like just the open source work, which is kind of what the catalog is for, just identifying the open source work. But as far as I understand, the OSPOs are interested in knowing just kind of like everything that's out there, and just filtering out by these different project types. But I would say the answer is both.
Are you specifically communicating that the non-licensed repositories are not open source software projects?
Am I communicating?
We haven't got that.
So for
some preliminary criteria.
Yeah, so for the catalog,
That to do you think that reach out to the projects or reach out?
Well, I was reading the paper really quick. I think it's nowhere in the, I scanned it quickly, but it doesn't have an open source license. Technically, it's not an open source project. So if the goal is to identify repositories that are affiliated with the institution, I think this does this. But if it's identifying open source repositories affiliated with the institution, then you have to take out that 70%.
yes.
That's what the second, so the
Right.
showcase only has licensed projects.
Yeah, and then so one of the things that I'm making sure for the projects that we're gonna have in the catalog is that they do have a license, and if they don't, then that is kind of part of the things that we're like talking to them about. It's like, you have a project that you want to share and you're in GitHub, and like, are you sure you don't want a license? But yeah, it's in the paper. So in the paper, I actually don't talk about a lot of like about the showcase, because this is kind of still mostly ongoing. The paper only talks about the all the data, like all the data that was collected, and the fact that that projects don't have a license I wouldn't dare to say they're not open source, because I think a lot of people might are missing the license for whatever reasons, or for example, GitHub doesn't identify the license for whatever reason. But I do think it talks about the nature of the projects, like what people are doing in the GitHub. But the OSPO is interested in everything. So I'm just kind of like keeping the data and figuring out how to filter out more things so that it's more useful. Yes.
I missed the first half of this because I was at the Open Source Summit one, and then I realized later that I don't actually remember some of the stuff in the Open Source one. So you may have addressed this. But is there any thought as to, is this going to be sort of like an ongoing scraper that would just be running and collecting all of this data, and you have some sort of database and like ongoing outreach and things like that? Or is the idea that this is going to be sort of a point in time survey of this and just for this paper? Like, is this something that you're planning to continue running as an ongoing thing?
So that's a hard question. For the showcase, for the smaller one, for the catalog, we're hoping that at least at first it would be built by like data that it's collected in this like way, but we are figuring out how to include other mechanisms so that people can actually add their own data, so that once we have a browser, something to show for, people will like be interested in putting the data out there. So we will have forums for people to show interest, even open PRs to add their information, and then like scrape data automatically. For the database, with like the whole amount of data, it's a little bit harder because again, it takes a long time to scrape all of the data. My guess is that it will be useful to have some periodicity to scrape all of the data. I would say not that often though, but I think there's a plan to do that, to keep the database hopefully like up to date. Any other questions? Okay, well, thank you so much.